Imagine you're cooking in a modern kitchen and your stovetop doesn't get hot to the touch, yet it heats your pan perfectly. That's the magic of induction. Let me explain how it works in a simple way. Induction is a way to heat things up using electricity and magnetism, without direct flames or red-hot coils. It's based on a principle discovered by Michael Faraday in the 1830s called electromagnetic induction. Here's the basic idea. Inside an induction cooktop, there's a coil of copper wire. When you turn on the cooktop, an electric current flows through this coil. This current creates a magnetic field that changes rapidly, flipping back and forth thousands of times per second, typically around 20 to 100 kilohertz. Now, this changing magnetic field is the key. When you place a special pan made of magnetic material, like iron or certain steels, on the cooktop, the magnetic field reaches up into the pan. It causes tiny electric currents, called eddy currents, to swirl around inside the pan's metal. These currents bump into the pan's molecules, generating heat right in the pan itself. That's why the pan gets hot, but the cooktop stays cool. This process is super efficient because the heat is created directly in the pan, not wasted on heating the stovetop or the air around it. It's also fast. Induction can boil water in about half the time of a traditional electric stove. Plus, it's safer since the surface doesn't get scorching hot and it gives you precise control over the temperature, like turning a dial from a simmer to a sear in seconds. To sum it up, induction uses a dancing magnetic field to make your pan heat itself. It's clever, clean, and a glimpse into how science powers our everyday lives. Next time you cook with induction, you're tapping into a bit of 19th century physics to make your 21st century meal.